Myself, Dr. Shubhankar Samanta, Assistant Professor of Vidhannagar College, wish to present another video regarding the NET question solution 2023 and the JAM examinations. Now we wish to discuss the aromaticity problem that has come in the NET 2023. There are two options. One is the heterocyclic compounds contain the boron nitrogen atoms. Another is also heterocyclic compounds contain the only boron atoms. And there are different type of options. That is the both compounds may be aromatic, anti-aromatic, or both compounds are aromatic. And one is anti-aromatic, another is aromatic, another is anti-aromatic, and any is aromatic. And in these questions mainly help to discuss the that in the UG syllabus. What is the inorganic benzene? Inorganic benzene means the which acid base complex type of, that is the nitrogen lone pair, is added to that of the vacant p orbital and produces the pi bond, and hence it is called as the inorganic benzene. Similar to that of the, we know that the boron atom can frequently added to that of the nitrogen lone pairs and produces the acid base complex, and this complex is also stabilized, governed by that of the Constant and Baxter theory. And this type of the nitrogen lone pair addition to that of the boron is applied here for the aromatic rule. Here the nitrogen lone pair is added to that of the vacant p orbital of boron and produces the pi electrons, and hence the both ring contains the 6 pi electron according to the Hooker rule, that is the 4n plus 2 pi electrons are present, so it is aromatic compounds. Another compounds like that, this compound is similar to that of the cycloheptatrinyl cations, where the cycloheptatrinyl contain the carbon atom, where the vacant p orbital is present, that is called also propylium cation. This is similar to that of the analogs of the propylium cation, where the vacant p orbital is present, and these vacant p orbitals undergoes resonance, and here this compound becomes planar, and hence it is aromatic in nature. So the both compounds are aromatic in nature, and from these two option is correct, that is that N and N both are aromatics. These problems is very interesting for the matching of the column A and column B. There are different type of the chemical reactions are involved. In these chemical reactions, in the cyclooctatetraene is present in the mainly top shape. When the potassium is added, that is the single electron is transferred to that of the top shape and produces the dianion, and this dianion becomes planar, conjugated, and aromatic in nature. And in the second case, that is the cyclooctatetraene is when protonated and produces the sp2 carbocation and the sp3 carbocation, and in this diagram it shows that the sp3 carbocation is the outer plane according to the homoaromaticity rules, that is the 4n plus 2 pi electrons and partially planar and partially conjugated, hence it is homoaromatic natures, and one of the sp3 orbital is out of plane. And in these reactions, that is the heat promoted distillation ring opening reaction, that is the electrocyclic ring opening reactions, and after electrocyclic ring opening it converted to that of the cyclooctatetraene, and it is mainly present in that of the top shape, and hence it is not considered as the anti-aromatic compound, rather it is considered as the non-aromatic compounds. In the last case, this is the 18 in the last case, that is the 18 aluminum 14 aluminum means here 1 2 3 4 5 6 7, that is means 14 electrons are present in nature. So 14 electron means it contains the 4n plus 2 pi electrons. When the potassium is added to it, it produces the dianion, and hence dianion means it contains the 16 electrons, and so it is anti-aromatic in nature. In the NMR and aromaticity rules, it has been shows that from that of the molecular orbital theory, it has been shows that there is a duet aromatic means here the bonding orbital is filled. In the dialectical cases, this is the 2 aniline system, and this is the examples of the 4 aniline system. This is the example of 6 aniline. This is the 8 aniline. According to the Hooker rule, the 4n pi electron contain the 2 electron in the dialectical forms. In the cyclooctatetranes respond to the 2 electron in the direct electron. In the NMR theory, it has been shown that if the compounds electrons are paired in nature, then just like that of the diamagnetic anisotropic, that is ring current effect is observed, and ring current effect, the ring current effect, the outer electron mainly present in the paramagnetic zone, that is the de-shielding zone, and the inner electron present in the diamagnetic zones, and hence the protons fall in the paramagnetic zone are de-shielded, and hence it has higher chemical shift compared to that of the diamagnetic regions. And so two aniline and the 6 anilines both are the diamagnetic regions. Protons are falling the diamagnetic regions, and the 4 anilines, 6 anilines, and in case of the 4 aniline, and in case of the 8 aniline, in this case the electrons are present in the parallel nature, so the inner orbitals are paramagnetic regions and the outer orbital in the diamagnetic regions. Means inner protons in case of the antiaromatic case, in the inner protons are falling the paramagnetic zones in case of the antiaromatic system, but in case of the aromatic systems, inner proton fall in the diamagnetic zones. That is, in case of the antiaromatic systems, the inner protons are shielded, but in case of the aromatic system, inner protons are shielded in nature. And hence, from this observation, it can be concluded that the protons, that is in case of the antiaromatic compounds, that is the 131, the inner protons resonate at higher regions, that is the 4 protons resonate at 10.56 ppm, whereas the outer proton resonate at 535 ppm. This is very interesting. This is the contrary to that of the aromatic compounds, where in the case of the aromatic compounds, if we look on the 14 aniline 6, in case of the aromatic compounds, the inner protons fall in that of the highly shielded regions. Suppose if you take that of these compounds, these methyl protons, this is the aromatic compounds, and these methyl protons fall in the negative chemical shift. That is the negative chemical shift of that. That is the higher ring current effect for protons fall in the negative region. That is that delta is the negative. But in case of the if the compound becomes anti-aromatic, when the compound becomes anti-aromatic, then this chemical shift of this methyl proton shifted to that of the higher value. This is the difference between that of the aromatic and anti-aromatic regarding the NMR theory. Now, if we consider that this is a very interesting observation, where the cyclooctatate of cyclobutadiene, and this is the mainly present in the 4n pi electron, so it can be considered as the anti-aromatic compound. But in practical case, this is mainly exist in that of the rectangle shape compared to that of the square form. The square form is converted when the FeCO3 is added due to that of the 18 electron concept, that is the here iron is present in the D8 system, and D8, and hence the 2 electron donor for carbon monoxide and the 4 electron donor for the cyclobutadiene, and total iron becomes 80 electron, and hence it becomes stable, and then the cyclobutadiene ring becomes planar. These whole things actually comes from that of the Jerry March groups, and additional understanding for March advanced organic chemistry. We can see that of the chapter 2 aromaticity. And here the 93, 94, 95. In case of the 93, 94, that is the ion system, and this ion pi bond is not considered for the aromaticity rule. That is that this electron is not counted here, and hence it becomes 1, 2, 3, 4. That is the anti-aromatic. One ring is 6 pi, another is 8 pi. This electron is not considered for the aromatic rules. And this, we know that this hydrogen, inner hydrogen, this compound contains the 10 pi electron. It should be aromatic, but in practical case, it is non-aromatic compound due to these two inner hydrogen atoms undergoes annular space interaction, and hence it becomes non-aromatic. So the things is that the planarity is the main condition for the aromaticity. The electron counting is not the condition for the aromaticity rules. For the consideration of the aromatic rules, you should consider the number of electrons, also consider the planar arrangement, and also consider the whole p orbital present in the same plane. Next, in the next video, in the next week, we will discuss about that of the aromatic addition elimination reaction regarding the problems that was come the 2023 examinations. And lastly, I am thanking to that of my scholar actually Paritesh Bari and Chandan for the help for helping this creation of the video. Thank you the students, and I am requesting for see the video and like the video and subscribe the video. I will discuss this problem in the next week in the next video.